I am going to present you today about Google Cloud Platform Cloud Workflows, a system which is the serverless orchestration and automation tool. Actually, it's a step engine, to say so. And let's start the clock and let's dive into the session. So, about me. I'm Marton from Romania, from center of the country, Târgu Mureș. I'm a backend developer at rea.net, a local company. I am for like 4 years in a row Google developer expert on cloud technologies. And I'm a top Romanian user on Stack Overflow, still growing, changing positions among a few of other experts there as well. My preferred products are BigQuery and Redis, where I'm considered also a database engine expert. All my slides, this one and others as well, are available on SlideShare. You can use my Twitter handler, Marton Kodok. And on GitHub and Stack Overflow, I have a different username, which is Pentium 10. So what's on the agenda today? We are going to see how difficult and what challenges are in connecting services. Connecting to service like two APIs, one step with the other, an internal and an external step. We are seeing that eventually there is a product to handle this, and one is Workflows, a HTTP-based service orchestration and automation tool, a step engine in other words. We are going to see what complex processes can be done in the workflows. We are going to use and run some practical use cases, and we are going to see how to automate, orchestrate, and provide reliable line of business automation, because this tool is something that it's one of my favorite tools. So when we are talking about connecting services, actually connectivity is something that nowadays should be easy, but in reality you need to figure it out. And because there is a different connection format, and you need actually, the best would be to have a common connection format, then you are faced that it's either HTTP based, it's REST, it's SOAP, it's OAuth or UEDC or API key authorization there. You will need to make the connections. You will need to parse the results, which is a component that you need to write, and always have a component fair with some library that eventually you need to maintain. When there is a step engine, then we see that decision and conditional step executions are among one of the features that people are developing, mainly, let's say, in-house or with a product. And they work a lot. Usually I need a couple of days to set proper error handling, logging, and even retries, which should be, I name these universal developer rights. So as a developer, I want out-of-the-box error handling, logging, and retries from the platform. I should not care about those. And the connectivity services are sometimes under burst, and sometimes there is nothing on it. And often product managers want us to actually scale up to, let's say, a Black Friday day and scale down to nothing. So these kind of challenges are that everyday developers face when they want to connect a piece of code, piece of services, eventually microservices or steps inside their application. Let's meet Workflows. It's a new product from Google Cloud Platform. It's under preview, in other words, under beta. And let's see what this platform offers for this kind of situation and step engine. So if you are going to analyze what is GCP Workflows, it's a step automation as a service. it's serverless, and it's managed, which means that you don't need to spawn on a virtual machine. You don't need provisioning. You don't need any containers or Kubernetes. It's managed serverless. You are creating a cloud account. You are setting up either the free plan or the billing enabled, and the service is there for you. In order to work and to come up with a language as a programming language for the workflows, they have implemented based on YAML. YAML is a syntax that gets familiar more and more in this container-based future. And with YAML, you are able to define all the steps in the workflows. You are able to handle JSON, even arrays, and a lot of other structuring as well. And YAML is something that's language agnostic. You can write it yourself as a developer, or you can even generate it with your familiar languages. I've seen people generating YAML syntax from Python, Node.js, Java, even PHP from their platform. As Workflows is a managed serverless service, there is a pricing, and the pricing is in steps. So here there is no request, there is no monthly upfront payment. It's based on steps. And there are two tiers here. One is internal and the other is external. Internal means that it doesn't touch the public internet, and external means it touches the internet. So you have, as you see, $1 for 100,000 steps, and eventually $2.50 for external steps on 100,000 steps. Next, there is a feature that I extremely like, and it's something that opened my eyes that, hey, there is a product that has expression formulas, it has conditional executions, I can operate on variables, I can do sub-workflows. It's similar to programming language. Remember, we will be example, and in the YAML syntax, the sub-workflow is a specific indentation part of the application. And it's out of the box support of API calls that are JSON first or OAuth or API key based. And normally it's a GCP product, so it integrates with any cloud product without worrying about authentication. The connection between the services is done based on service accounts and proper permitting by roles and individual authorization of this based on the service key. So what steps are supported? It's just a quick list. It's not a full list. So there is the basics, invoking a HTTP endpoint. Another step is assigning a variable or building a dictionary. Often you need to come up with a variable. I would name sleeping as well is important because sometimes you want to wait for a step to finish. And creating the logic for conditional jumps and returning a value is, of course, considered a step because a workflow could be as simple as just returning a value. So let's see the hello world example. In this screen, actually, what we have is hello cloud workflows. So we have a YAML file which defines a name for our step and one subaction, as I mentioned previously, returning a value is a step as well. Often people forget about this. So just to write hello workflow is having this YAML file ready in one of your folders. Then you get the SDK of the G Cloud. And of course, you can do the interface as well, but this screen says and tells you how to do from the command line, how to try out as a developer, deploying a function, deploying a workflow. So if you have the G Cloud, Under the beta and the workflows, there are a couple of commands like deploy, execute, and list. And one is deploying the workflow. You pick a name for it. That's what hello says here. And you have the source for it. Next, you want to execute the workflow. Yeah, for this, you just call actually from the command line this code, but you can execute the workflow either from a scheduler or from the API request as well. When the workflow executes, it creates a specific item of it, like a request, and based on that request, you are able to describe that kind of execution. And when you analyze the execution, you see that which revision ID is being executed, if it was input parameter or not, but in our situation, there was no additional params as an input parameter when it started, eventually when it finished a project and description of the execution. There is a hash which starts here. That's actually the execution hash. And the result, which now is a plain text, hello cloud workflows. And of course, the state succeeded, because there are also failed execution and retry executions and all kind of developer-friendly processing here. So when it comes to executing a workflow, there is the Google Cloud Console, of course, when you start developing for it, but from the G Cloud and from the terminal or shell, you can run workflow execute. You say here the my workflow, eventually additional data you want on the command line. Or if you want to trigger executing a workflow, for example, based on an event or based on a HTTP API request from any web service, you need a service account in order to have this authorization builder set up. But when you are in the cloud, you have this available on your machine, on your instance, or your cloud function or cloud run terminal, whatever that should be. And this is the syntax execution of the workflow name and data. You can set here parameters and the value for that. So when it comes to explore some sample workflows, let's dive first and let me show you how this is happening in this situation. So there is this product workflows, which is cloudgoogle.com/workflows. Here you get a bunch of information about documentation, use cases, complex automation, like let's say new e-commerce order received, you want to generate a PDF, you want to encrypt it and send the invoice. This could be a step for that. You could have also, for example, a shipment execution on inventory levels, where you have a decision tree, and based on the decision tree, you get also to trigger and use a supplier's API, which is external to the system that you have built, and all kind of features and pricing of this information. This go-to console goes you to your console where there is a project set up. And of course, if you don't have nothing to it, it's much more simpler here. You are able to find workflows either by using this search. Here you see workflows, product and pages workflows, or by the menu, and you need to scroll down, and here in the tools section, you have workflows in the tools section. So that leads us to getting familiar with the workflows interface. I won't spend too much time here. There are some workflows I already added in here. You are able to create a workflow by defining the name of it, eventually a description, and it comes up. This is a template that starts with, and here you put your YAML. You are able to deploy it and execute from the interface as well. Let's go back to our presentation to go further with the options that we have and I prepared a couple of syntaxes and sample workflows for you. So the first one is how to make a simple HTTP GET request. So you have here, let's see, pointer. So you have here the YAML file where you have two steps. One is read Wikipedia, the other is return result. This is a type HTTP GET. You have the arguments, the URL, and here you have the query. You will see that the post request here has the body. And you say here action, open search, search Dacia, a brand, a car brand from Romania. The results are stored in the VQ result variable, and you are returning the body and the first item. Here is the snippet, what it's being returned, and you will eventually see that Dacia Spring, which was launched last week, it's not returned. So probably some folks need to work on Wikipedia. And then the new model, which is full electric, Dacia Spring. Okay, let's continue by issuing a post request, but instead of showing you slides, I actually can show you that in VS Code, I prepared some examples for you here. So let's go and run a couple of examples. How do I run the example? So the example is that I have the terminal here. I have gcloud available as a command in the terminal. Of course, I just tested right now what it to do. And in order to run it repetitively, I want to automate things. So Visual Studio Code offers you how to decide, how to define IDE tasks. And that's in the VS Code tasks folder, where you are able to define the name and the label of the workflow. I also use the plugin, like the Quick Run plugin here, which defines and puts as a panel how to deploy and how to execute a specific file. What this command does is that it's type shell, so it will mimic the shell, and this is the command that is being used for deploy. What you see here is that the source of the file is as a parameter, and I use the name from the file without extension as the name for the file I am actually creating. Of course, the same with the execute as well. I have the name of the workflow item, which is here based on the final execution. So when I go back with the hello YAML example, I have only 2 lines, the name of the workflow and a command return. I am pressing deploy. It will open up here, and you will see that the command is this one. So the command is this one, where you have gcloud beta workflow deploy hello. That's a wrong format there, but it's hello. You have the source of the file, and of course you will have the output of this. So this is just a deploy. Ooh, where it is? It's so hard to exit from here. I will switch now to a different terminal screen here, and I'm going to actually click execute on this workflow, which is running gcloud beta workflows execute gcloud beta workflow execute hello, and it returns me another command, because each execution is a different one. I want to actually copy paste this and put in a different terminal window to see what our function or what our steps have done. And I'm seeing here that the state was a succeeded state, and I have my return as a result, a string hello cloud functions. So this is extremely repetitive, and you are able to quickly run through some examples. Now, previously I've already shown you how to do HTTP GET. So you need only this. You click deploy. You wait a couple of seconds for the deploy to actually happen. It's done. You click execute. It's being executed asynchronously. You need another command to get the results, and here it is. There it is. That's your result. If I want to change something here and I want to use Tesla, I am deploying it. I wait a couple of seconds for the deploy to finish. I click execute. This is repetitive tasks by the VS Studio in order to make it quicker, this operation. And I have the command to see the execution. And as you see, here is the output. So to see you and explain what it happened here is that this body is executing 2 steps, and I had to use only 10 lines of code to actually run a get statement. Good. So next, I'm going to show you the post. Post is extremely important because a lot of APIs are only handling post requests. And of course, there is authorization, and we need to see how easy is it just by adding headers to it. And this is a key that I set up only for the sake of the presentation, and I implemented the Bitly link shortener service. What's going to happen to here is that Bitly has this API, which works based on the token, and in the body, it accepts a document, a JSON document, as it says here, a JSON document with these keys, domain, long URL, and the result is stored in this variable, and I'm printing the body. So I'm going to click deploy. I'm waiting to actually finish this, and the deploy is finished. I'm clicking execute. The execute will show me how to read the commands. I'm showing this from the terminal, but with the API, you are able to automate this from your own application. What you see here is that I got back a JSON structure, and the important thing is that the link, which is the short link, is in here, as you see, is there, so I can use this. And if I was to change the domain, for example, EMP, which is also supported by their API, I'm going to deploy, then I'm going to execute, and the execute command gives me how to read the response. I'm using the response, and now, as you see here, I got the EMP. You may wonder that this is just a basic example to show you how easy it is to actually do a step engine inside the cloud. This runs in the Google Cloud Platform. And if I go back to the screen, and I will reload the screen, HTTP post is here as a workflow. If I click it, I will see the executions. Of course, there are some failed ones until you get it going. You click to definition, and as you see, EMP is the most recent version, which is from our code base. So it was around, let's say, 5 to 10 minutes to get an example copy-pasted and run without initializing a VM. It wasn't a container necessary, no Kubernetes engine, nothing. So if I go back to the presentation, there are a couple of examples that are added in here. So if we want to segment steps, because actually the step engine is about that, so being a workflow, you need to have a workflow for that. This means that you define the steps, pointer, I want a pointer. You define the steps, which is get current time, read Wikipedia, and return results. And here you have the get statement, for example, to read the current time. From there, I will use, from the current time execution, I will use day of the week, and I'm going to pass to Wikipedia API as an open source. So day of the week is Saturday. I'm expected to actually this call to return something Saturday-ish, and the API to use the search term Saturday. Let's see how that works. So in this example, Wikipedia here, let me close this. So I'm going to deploy. I'm going to split the pane while it deploys. I'm going to execute, and I'm going to view the execution, this execution's output. So as I expected, it's something Saturday-ish. So Wikipedia API returns these messages for Saturday. So going further, a couple of more examples for you. The switch block. I expected, when I read that workflow support switch block, I expected something nasty, something complicated. But hey, look here, it's extremely simple. You have the conditional switch as a step. You say not a call type, it's a switch type. And you have the algorithm to actually let you to write the condition. And with the next keyword, you are jumping between the steps. So actually Friday here is another step which is defined down here. And what's important is that the switch statement, as we know in the programming languages, it has a default one. So you see here, work with is something that's a default of the switch statement. So this is combined. You can combine a lot of steps, even from, let's say, inventory handling, or sending an email template based on a parameter, customizing the workflow route, where and how to do, and all this by looking at one single YAML file. And I need to emphasize here that the YAML file can be generated by your favorite programming language. That means that you can build a visual thing in order to put together a workflow. For example, imagine for a marketing campaign, putting together a workflow, which would be the first step to identify the event that the marketing campaign starts. It could be something that loads then the user, and based on the user, it should, let's say, the user's products. It could be that you send a template offering them a specific product with a specific design, or you are sending a follow-up or a push notification. And this kind of automation, you don't need to actually build component inside your product. You can take care of the workflow service from GCP. Some more advanced way, you are able to declare a dictionary and an array. And this comes helpful for programmers because often there are shortlisted variables that you want to take care and defaults that you want to define as a variable. So assign is a special construction here, and you can here define, for example, the name in case of a dictionary or for an array. And you have a couple of ways to define variables and arrays. Of course, people may ask, if I define an array, how do I use it, or what's the use for? So there is an iterating array construct And what you see here is that it basically uses a define section where you define foo and bar as a separate R item. You have a result which is initialized at an empty string and a step variable which is 0. You have a switch statement which is the condition. In case the condition met, it does iterate. Otherwise, it does an exit loop step. And the step with exit loop is actually returning what the result variable have obtained during the execution. And in the iterate phase, the step is going to assign for the result the previous result and a new item from the array and the current cursor if I name it that variable. So it's a declarative way to actually process arrays and run these examples. So I'm going to show you, I'm going to show you a couple of more advanced syntax ways in order to get the feeling of the system that you have a lot of flexibility. So you are able to evaluate expressions. So here you define last name, and you are able to use full name and the name and the last name. You are able to actually convert temperature, which is an int value, to a string value and use that. So expression is handy if you get from one API one kind of format and you need to cast it into the other format as well. Subworkflows. Now, these are extremely helpful subworkflows because you can maintain them as an individual piece of subworkflow as a workflow, and you can combine your YAML file by generating these items and including at the end of the file. So subworkflows work that they have a special syntax like call, and there is a name for that, and the name message is actually a subworkflow defined at the end of the file. So you have a main construct, which are the main elements of your workflow, and then individually the subworkflows. We use these to actually reuse code bases because we have fragment workflows, which we just include at the end of the file. And here are the parameters and the name of the workflow as well. As you see here, first name, last name is a parameter to our subworkflow. So next is one of the developers part of it is catching and handling request errors. So here what we want to actually look at is that this is a continued example to fit on the screen. The read item is a step which has a try and except execution. And in the try section, you have your regular code, and exception is something that you are going to handle it. You can handle the exception based on tags format or other exposed data into the exception variable, or you can use based on the HTTP response code or those kind of things. People have asked me previously that what happens if there is an unhandled exception. Well, the execution fails, and you will see the execution inside your log platform, and you can implement later on. And these exemptions are actually they are added new ways to actually handle responses and how to say it. So the platform still adds new ways to actually detect developer friendly and developer universal right problems. Retries. So retries is one of my favorite things because I don't need to implement them. I just need to define them in 10 lines of code. Often when I develop automation inside our product, I spend a lot of time to handle properly retries and all kind of details and parameters and actually having a backup of the retry section. So suppose that you are familiar with, let's say, message queue systems. The retry section reassembles the message queue retry section, which you have there, for example, a predicate. You are able to actually find and define a predicate how the retry is going to handle. There is a default retry predicate, which is basically these status codes. And 500 is considered mostly the retry algorithms predicate. You are able to set the backup and the multiplier of this system. And this is a straightforward example. We are using it once in our get sub workflow, and we actually use parameters in our get workflows to keep the example minimum and reusable. So I have a question on the chat which asks if I can configure the timeout. Yeah, it's not in the screen as well, but you are able to actually use on the call section a timeout as well, and you can add there the value of the timeout. So let's see conclusions. So Google Cloud Workflow is, I would say, it's a clone of your best handyman. It does all the things that a handyman does inside your organization. It can automate, orchestrate, provide reliable line of business automation. And here in our examples, I didn't put inside Google examples like using a response from a cloud function, using a response from a database, but those kind of line structures are available. And you can, for example, use from Firestore a line to actually get an item and another one to write it, just as a 5 lines of code. Or you can automate all kind of services like run a function, get the results, or the results are routed further in BigQuery, and you can automate all these syntaxes for your step execution. The benefits. Mostly they are developer-friendly benefits, but let's see first how we can summarize what are the great benefits. So it provides us a reliable workflow execution, and it's enterprise scale. You don't need to actually take care of any administration and provisioning. It's serverless, it's managed service, and it just works out of the box. It has low latency, no cold starts. You don't need to wait for a VM to boot up. You don't need to wait for a cloud function to boot up or a container to boot up. It has out-of-the-box error handling with configurable retry policies, as we have seen. It's built in JSON parsing, expression-based variable manipulation, which comes handy for programmers, and they don't need to build out functions to do this, because people have asked me previously that, what if I don't have an expression-based? You can put that as a feature request into the workflow, but if you need something custom, then you may eventually implement a cloud function for those, and it will provide you the manipulation that you want based on the input. It provides rich runtime, and as I mentioned, you can write and read from Firestore using the YAML syntax. Of course, it has out-of-the-box integration with cloud logging, so you don't need to develop log collectors and alerts on errors and so on, because the GCP platform offers that for you. I put this slide here because I wanted to have a second view just for the developer-friendly benefits. It's easy to build and operate. It's just YAML. It scales out, so it scales down to 0 which is my favorite because I don't need to skip there an engine up all the time. It does not lose state, so it has retry and it doesn't lose state. Handles errors. It has out-of-the-box support for the APIs, and nonetheless is auditable because